We are starting with chapter 5, problem solving methodology. In this chapter, we are going to study about to understand the process of problem solving, concepts, features, methodologies of problem solving. Let's explore this chapter number 5. So here, the problem solving. The term problem solving is used in many disciplines, sometimes with a different perspectives and often with a different terminologies. For instance, it is a mental process in psychology and a computerized process in a computer science. So here we are going to observe computerized process. In computer science and in the part of AI, artificial intelligence, that deals with the algorithms, problem solving encompasses a number of techniques known as algorithms, heuristics, root cause analysis, etc. In these disciplines, problem solving is a part of a larger process that encompasses problem determination, duplication, analysis, and diagnosis, etc. See, now problem solving can be considered as so it may be any kind of problem. Generally, if we see theoretically, not as per your subject, right? Assume that in 2 days you'll be having your midterm exam, and suddenly college people gives you some assignments and presentation. So now this can also be considered as a problem. How? In 2 days I have to get ready for my exam, and along with that, even I have to uh, I have to prepare, I have to do the preparation. Along with that, the given assignments and presentation has to be completed. How to complete? What plan you do? How do you schedule your time to these three tasks? That is also like problem solving only, right? So today's almost all fields of human life sphere are computerized. Everywhere we are seeing the computers. Some of the major areas are scientific and engineering, education, commerce, etc. Scientific and engineering problems are mathematical oriented. Commercial field problems deals with record keeping, accounting, and so on. Whatever the kind of problem solving using computer needs to follow step-by-step methodology to arrive at an efficient solution, right? Whether it is a scientific and engineering or it's a commercial based problem, whatever may be the problem. So here what happens is problem solving needs step-by-step methodology to arrive at an efficient solution. So man-machine interface. So here man-machine interface, man in the sense programmers or the users. Machine is here computer. Interface is like media through which a user or the programmer will be communicating with the machine through an interface. So computer works on set of instructions called computer program, which clearly specifies the way to carry out a specific task. In early history of computer, it was felt that every computer user needs to know a great deal about computers. That is what they need to learn machine language or assembly level language. And all of you know very well that to learn these languages, one should have a in-depth knowledge of architecture of computer, right? So where this knowing the architecture of computer, then only machine language you can learn easily. And machine level language and assembly level language, like these are machine oriented languages, whereas high level languages such as Fortran, COBOL, BASIC, etc., which are machine independent languages. Computer understands machine language only. Hence, programs are developed in a language other than machine level language needs to be translated into its machine language version. So as there was very difficulty in learning machine language and assembly level language, right? So they developed high level programming languages where we were writing all the commands in the simple English statements, where these simple English statements were easy to remember, easy to write, easy to make corrections, right? So, but when you are writing in English, computer doesn't understand your English commands. It has to be translated into machine language. So for that, translators got developed, like assembler in assembly level language, interpreter and compiler in assembly level language, sorry, high level programming language. So here each new programming language is designed to improve the man-machine interface. This progress is improving the man-machine interface leads to the questions of who needs to learn computer program and what can one learn about problem solving through studying computer programming. Thus, computer courses are placing increased emphasis on problem solving in computer environment. Right. So, what are the different? The problem solving process starts with problem specification and ends with the concrete program. So, what are the steps involved in that? Problem definition, problem analysis, algorithm development, coding, program testing, and debugging documentation. These are the different stages of solving the problem computer environment. So now here, what is this problem definition stands for? See, whenever you are solving the problem, first you must know the problem very clearly. You must know the problem first. Then only you can find out the solution. Without knowing the problem correctly, the solutions can't be created. So how in practice to solve any complex real problem, there are some questions below for which you need to answer. By that, you will come to know what is the problem definition, why you want to develop the program, why you want to do that problem solving. First, what the computer program does, what tasks it will perform, what kind of data will it use, and where will it get that data from? What are the sets of data you are going to use, and from which source you are going to get that data? What will be the output of the program? How does the program interact with the computer user? These are all questions you need to answer, so that for any problem, if you get the answer for all these questions, that means you know what is exactly the problem to be solved. Right. So here, specifying the problem requirement makes you to state the problem clearly and unambiguously, and to gain clear understanding of what is required for its solution. So with this, what happens? You will get complete clarity on the what is the actual program. All right. And now, one more question what arises is, in this only understanding these 5 questions are only not important. After creating the solution, you have to check what all the unwanted things, unimportant things are present in that. So that if you remove it, your program will be, your problem solving technique will be still more very efficient technique. Right. So problem analysis. Analyzing the problem or analysis involves identifying the following. First one is input, second one is output, and third one is any additional requirement. Input means what? The data, what you are going to work with your program. Output in the sense what? The desired result. And third one is what? Any additional requirement or constraints on the problem. Constraints in the sense what? When the input data is being supplied to your program, means your program should check whether the data given is correct or not. If it is correct, take it into the program. If it is not correct, then stop execution, come out from that, make corrections, and again you can resend the program to it. Right. Now, design of solution. We represent the solution to the problem using the tools such as algorithm and flowchart. So the design of solution will be from flowchart and algorithm and flowchart. Right. So we are going to see all of them one by one in detail. Algorithm development. Algorithm means what? For any problem solving. Once if you know mathematically what is the technique allowed to solve this particular problem, right? And then what you have to do is you have to write the step-by-step procedure and then verify that the solves algorithm solves the problem as intended, right? So we assume that the word algorithm has been derived from algorithm, which means the process of doing arithmetic calculations. But in addition to it, we have attached many words, right? So now here, this algorithm is the word from which algorithm is created. And what is algorithm? Stands for process of doing arithmetic in Arabic numerals, right? So a Arab mathematician called Muhammad al-Khwarizmi, it is combined with the word arithmetic, and so an Arab mathematician Muhammad al-Khwarizmi, it is combined with the word arithmetic to become algorithm. So what are the characteristics will be there? There are 5 basic characteristics. One is input, second one is the definite, third one is effective, so here the first one, input, stands for an algorithm starts with procedural steps to accept the input data. First, in the initial stage itself, for that problem solving, what are the inputs required? Inputs in the sense what? These are the set of values what we are passing, right? On your phone, kindly so those all variables, the input data, whatever we want to accept, should be there in the beginning. It may be one or it may be more than one to retrieve the value. Definite in the sense an algorithm should contain, right, each operational step or operation must be definite. Each and every instruction must clearly specify that what should be done. And effective in the sense what? Here, like whenever we are solving the problem, there will be a multiple solutions will be there, right? In that, you have to select the effective solution through which, if we carry the calculation, it should take less memory, right? And terminate in the sense what? Algorithm should also have some point through which we can say that this is the best solution through which this problem can be solved, which takes less memory, less space. Terminate in the sense an algorithm should provide you terminate condition, right? Output in the sense they must produce, right? It should come out from some particular point. Output in the sense what? The result, what we had expected, whether it is coming the same result or not. See, now there are some sample algorithms have given here. With this, you will come to know how algorithm can be written. First one for compound interest. So the formula for calculating compound interest is, so it is compound interest equal to, it is CI equal to P into 1 plus R divided by 100 raised to T minus P, right? So this is the formula. In this formula, the value for whom I have to provide it, no, there are 4 names. P already calculated, one, sorry, not calculated. One variable is P, another is R, another is N. That is, they have taken as N only. So first you have to input these 3 values and calculate the compound interest using this formula and print the output answer and end of the algorithm. So these are like main words, should be there always. Below that you have to write here command. Now one more example, greatest of 3 numbers. See, they have taken start. After that, read the 3 number. Pseudocode is input A, B, C. Then assign A to the large. Large is having a variable called A. That A will be assigned to right. If it is, when it is assigned to larger A, large variable A, that number will be compared with all those other right, other than all those remaining numbers, right? So if B is greater than large, then B will be assigned to large. So either this or this, any one condition will be checked out, right? And now, so now there is factorial of a number. Factorial of number means what? If there is a number 5, its factorial is 5 into 4 into 2 into 1, right? So how to calculate the product of that? We read number input n, initialize factorial to 1. The output variable factorial must be initialized to 0. So compute the factorial by successive multiplication. How? There is a for loop they have given in general. So now here repair for x equal to I to 1. Now here this for loop I equal to 1 to n, where that I successively multiply its value with the value of fact. Then the final value will be stored into fact, and later on that fact is printed. Now there is an algorithm to find out Fibonacci series. What is Fibonacci series? See, all time I'm saying that whenever you are solving the problem in computer, first you must have a knowledge of how that problem can be solved using mathematics. That you can convert into program. That is very important. See, in the Fibonacci series, what happens is there will be two numbers initially, 0 and 1. If you add these two, you'll get next one. If you add these two, you'll get next one. Again, you add, you'll get next one. So like this, it continues. If I consider the starting number as A, ending number as B, right? So here, they have taken a value n. They have initialized first variable to 0, second as 1, and term is equal to 2. Print first and second. First is 0, second is 1. And now here print first comma second. That means in the first and in second, what we have 0 and 1, those are the two predefined values for this formula. Hence that has to be printed. After printing that, it will open the third. It will go for this equation. And then it will check while term is less than or equal to n. That is less than or equal to n. In such case, print the third number which was calculated here. And then second you assign it to first, third you assign it to second, and third should get the addition of first and second, and term is incremented by 1. So like this. Now the explanation about it. Greatest common divisor. There are two numbers given A and B. So you need to find out the greatest common divisor. For that, see what they have done. Repeat while B not equal to 0. Okay. Repeat while B not equal to 0. First, they are finding the remainder of A by B. Then B will be assigned to A and R will be assigned to B, so that next round A and B are ready with the next question. The next iteration of loop. And at last print A and exit algorithm. Right. Analysis of algorithm. There may be more than one approach to solve a problem. In mathematics, you can see that whenever there is a problem, some equation is there, usually there will be a multiple solutions. That means in multiple methods, you can solve the same equation. In the same way, whenever you are solving any problem in computer also, as in mathematics, when there are multiple solutions, the same multiple solutions will apply here also. That means what? Multiple solutions will be there. That means multiple algorithms will be there. So the choice of algorithm in those multiple algorithms or in those multiple solutions, right? Which algorithm you are going to select, that all depends on what? The performance of analysis and it depends on the performance analysis and measurements. There are 2 points based on which the algorithm analysis can be done. One is space complexity, another is time complexity. Space complexity says how much memory it is consuming. That algorithm, how much memory it will consume to complete its execution. Time complexity, the amount of time the algorithm needs to complete the process, the problem, the execution of the program. When we analyze an algorithm, it depends on input data, right? There are 3 cases: best case, average case, worst case. The best case can be said the amount of time a program might be expected to take on best possible input data, right? The amount of time a program might be expected to take on best possible input data is best case. Average case is what? The amount of time a program might be expected to take on typical, that is on average input data. Worst case is what? The amount of time a program would take on the worst possible input configuration. Then time-space trade-off. The best algorithm or a program to solve a given problem is one that requires less space in the memory and takes less time to complete its execution. But in practice, it is not always possible to achieve both of these objectives, right? So usually what? The best algorithm or the best program can be said the program which is taking less space in the memory and takes less time to complete the execution of the program. But in practice, what happens? Practically, if you speak, right, these 2 things always it is not possible. One algorithm may require more space, but may be taking less time. Another may be reverse. Thus, we may have to sacrifice at the cost of either other. If the space is our constraint, then we have to choose a program that requires less space at the cost of more execution time. On the other hand, if it is our constraint, such as the real-time system, then we have to choose an algorithm or a program which takes less time to complete its execution. To complete its execution at the cost of more memory space, right? So stepwise refinement techniques. So there are several steps to reach a program from mathematical model. In every step, there is a refinement, that is conversion. That is to convert an informal algorithm into a program. That means what? The process of converting the problem from algorithm step up to the final step program, there will be a refinement process will be there or conversion process will be there, right? Like how you study life cycle of something, animal, human being, or it may be a plant. So let's see how in that, like refinement will be there, conversion will be there from every stage to stage. In the same way, here also what will be having that refinement. So we must go through several stages of formalization until we arrive at a program whose meaning is formally defined by programming language. Manual is called as what? Stepwise refinement. There are 3 major steps in this. See, first, mathematical model. That means what? As today the last part we discussed that Before we start solving any problem in the computer, first find out what is the mathematical solution available for it. That is a mathematical model. That is our informal algorithm. That solution itself will become our informal algorithm. After that, what happens is formal language is required, pseudo language. Second step of refinement, the informal algorithm will be converted using pseudo language. That solutions, right? It is converted to a pseudo language, which is the second step towards making the final program. Later on, what do you require? You require data structures like C, C++ programs. With the help of that, those pseudo language can be converted into a program. The development can be expressed as pseudo code. One more is flowchart. What is the pseudo code? In narrative description of the flow and logic of the intended program written in plain language that expresses each step of the algorithm. So now here, pseudocode in the sense what? A narrative description of the flow and the logic of the intended program, right, which will be written in a plain language. That is nothing but what? Pseudocode is nothing but an algorithm where the mathematical informal algorithm, the mathematical solution or a mathematical model to solve the problem, whatever we have, that will be converted into a series of sequential steps written in a plain language, right? Those all steps becomes a step in the algorithm. Then what is flowchart? Flowchart is the graphical representation of an algorithm which demonstrates the process of solving the problem. That is what? Flowchart. Right. So that graphical representation that uses graphic symbols and arrows to express the algorithms. So let us go little more depth in the topic of flowchart. So the diagrammatic representation of an algorithm is called as flow. In general, say for example, earlier when this internet was not there, like say we are in some big city, say Bangalore. Some of our relatives are coming to the Bangalore and they want to go to some particular place, right? When we are in Bangalore, so they ask us, we want to go to that place. So how to go? Which bus I have to catch? Which stage, which sub-stage, which area I have to go to that particular location? Then we used to say verbally, first you go to the Majestic, take this bus number, there you go for third main stage and third cross. In that, this kind of apartment will come. In that third floor, this building is all verbally will say. When we say all these things, no, sometimes even in that main stage, you get 5 crosses. In that, you go to third cross, then you take a left turn, then you go straight, 2 crosses will come, then you go to right side. If you say all these things, no, they'll get confused. The verbal explanation, then immediately they'll say you that. Can you do one thing? Whatever you are saying, you just put it in a writing, like a steps, like a small diagram, so that I can go through it, so that I can easily read. Otherwise, I need to call you again and again for this. Then when they draw the diagram of moving to that location, they felt very easy. And this diagram, what we were doing earlier, that is only now it's a Google map, which is helping a lot of people. Like that, when the problem solving, right, the first step, what we do, the mathematical solution, we convert it into an informal algorithm. Later on, we are going to write that series of steps in a plain language, right, like algorithm. That algorithm, which will be in a series of steps, right? It's like verbal communication. When I want to explain those verbal communicated series of steps to someone to solve the problem, may not these steps will give the complete clarity of the solution of the problem. In such case, if I represent those steps in the form of diagram, then they'll understand it very easily. That is why flowcharts are introduced. Flowchart are the graphical representation, diagrammatical representation of an algorithm. So they play a very important role in the programming to solve the problems, to understand the logic of complicated and lengthy problems, right? Once the flowchart is drawn, it becomes very easy for the programmer to go through the flowchart and start writing the programs in the high level language. That is why here the flowcharts are introduced and they help you to solve the complex problems very easily. There are two types of flowcharts, program flowchart and system flowchart. Program flowchart specifies only the flow of operation of an algorithm, pictorial, but program flowchart never specify the computer environment in which the program will be executed, right? A system flowchart is a flowchart which gives an overall view of a computer system environment in addition to the flow of operations for an algorithm or program to be solved. Both will be there in this, right? See, it gives you the overall view of computer environment along with the flow of operations, how that program has to be solved, right? That is all handled. That both the things will be there in the flowchart, a system flowchart, right? It provides information such as whether the program is stored on magnetic disk, whether the data is coming from the keyboard, and even the result also, whether it will be printed on the paper, or it will be shown on the monitor, or it will be saved into the disk. All the complete process will be shown. That is system flowchart. So the importance of flowchart, why we need. So here algorithm and flowcharts are very important topic in first year. They'll give you a questions on algorithms to write algorithms for different equations like compound interest. Yesterday we have seen, in the last class we have seen those all things. So, and flowchart also is what? It is an attached component with the algorithm. They may say you write an algorithm and draw a flowchart to compute compound of interest, simple interest, to calculate average of numbers. That is why understanding these two topics are very important. Communication, in the sense, flowcharts are better way of communication of the logic of the program to all concerned, right? That is communication. Effective analysis. With the help of flowchart, problem can be analyzed very effectively, and this is the effective way of analyzing the problem. And because of the flowchart, the program documentation will be done very in a proper way, which will be helpful in a various purposes. And because of the flowchart, a programmer can do the coding properly so that the intended problem can be solved and the expected outcome of the program will be accurate. And because of the flowchart, easily I can identify where exactly there are loopholes. It is something like proper debugging. I'll tell you, there is a big apartment. Assume that in some of the houses, there are say 200 houses. In some of the houses, there is a like means what, like say drainage supply, it is not happening properly. In that case, what they do, they'll be having a diagram of pipelines, what they have done in the apartment. By seeing that diagram, easily they'll come to know where exactly it is blocked. Because of that, drainage water is not going out. Like that, when the proper output is not coming, then with the flowchart, easily we can do it. Right. Easily we can do the debugging process. Then efficient program maintenance. The maintenance of a program becomes easy with the help of flowchart, right? And these are the symbols. These symbols are important. You need to remember, because while drawing the flowchart, these are all things you require. Let us go through all these symbols one by one. The oval symbol, which indicates the beginning and the end of the flowchart. In the algorithm, you had seen, no, the first step was start, the last step was exit or a stop. To indicate those steps, you have to use this symbol. Parallelogram, this is used to indicate input and output operations. Rectangle to indicate the calculations or assignment. Rhombus, which is like a diamond box, but name should be named as rhombus only. Decision or branching purpose. Preparation symbol, this one, it is for looping, for repetitions. And this one for representing predefined process, that is subprogram. It is different from rectangle symbol. There are two extra lines inside. And a circle symbol called connector for showing the connector, right? For example, in my flowchart consuming 3 pages, how I should indicate that the continuation of the first page is in the second page. So you can use this connector. Arrows, the control flow, the flow of control, the flow of process will be indicated by this symbol. Remember all this, practice drawing all these symbols. These are very important in drawing flowchart. Now we are going to move through more than one example, how to draw a flowchart for different problems. See, flowchart to interchange the values of 2 variables. See, first of all, let us first, as I said already, you must know the manual process of interchanging the 2 variables. What is the meaning of interchanging the values of 2 variables? See, suppose if A is having a 10, B is having a 20, right? These are inputs. My output should be what? Reverse. A should get the value of B, B should get the value of A. This is called as interchange. But how it can be assigned? For that, one example is there. Assume that there are 2 glasses. One glass contains mango juice. Another glass contains full orange juice. Both glasses are full of juice. One contains mango juice, another contains orange juice. Now you have to interchange the contents of these 2 glasses. Orange, let's name the mango juice glass name as A, orange juice glass name as B. Orange juice should come into the mango juice glass, and mango juice content should come into the orange juice glass. But both are full. How will you interchange? You need one more extra empty glass, right? You need one more extra empty glass. That we will think it as 10. So first what we do, the mango juice content will put it into the temp, right? A got copied into temp. Now A glass is empty. In the A glass, now we will pour orange glass juice. So B glass empty. In the temp glass, we have A glass content, original, that will put it into B. Like this, you must know the manual procedure, then only you have to go for algorithm and flowchart. So first start, see the symbol, and then input. That means what? We need to take 2 values. Which are those 2 values you want to interchange? Then computation, calculations, assignments, through which the swapping of 2 numbers can be attained. See, those same steps are written. And here output A, B. After swapping, I have to print and show it to the user that the values are interchanged, and then stop the process, right? Similarly, there is another one to find the area and circumference of circle. Before you go to that, what you should know? Area of circle and circumference of circle formula you should know, right? So area of circle is pi r square and circumference is 2 pi r, right? So here area equal to 5 means 3.142 into R into R. Circumference equal to 2 into 5 into R. That means to solve this area of circle, I should know the value of R. Here also I need the value of R. Without that, I can't find out this area and circumference. That means my input is what? R. And what is my output? Area and circumference. So what do you do? Area equal to, so first start, then the input symbol has been taken. Inside that input, RAD stands for radius they have written. And there is no rule that for radius you have to write RAD only. If you want to write completely or you write shortcut R also, it is left to you. There is no standard saying that you for radius you have to write RAD only. You can write any name for this. RAD. So these names should be in such a way that by seeing the flowchart, who is going to do the program? No. For them, it should be easy to understand what RAD stands for. They should not come back to you and ask, what is this RAD stands for? And then compute box, where I'm writing the formula of area and circumference, because once I get the value of RAD, I can easily calculate area and circumference. And then print area and circumference and stop. Similarly, now area and circumference, is it repeated? This is also area and circumference. Flowchart to find the area and circumference of a circle only they have given, but formula is different. I think this is different formula, maybe triangle or what you see, only check it out, right? Okay. So some objects, area and circumference, they are calculated, right? Where here there is, as per these two formulas, they need input of S1, S2, S3. So input S1, S2, S3 by using input box. And in the compute box, they are writing both the formulas, then printing the area. That means what is happening? Whenever you want to draw a flow chart, first you should know the inputs for that calculation. Take the inputs of that, then write the calculations in the compute box, then print the result in the output box. Then stop. If I want to find the greater of two number, then start. I need to ask for what are those two numbers. Then I'm going to use rhombus box for comparison. I'm going to check, is A greater than B? T stands for true. If A value is bigger than B, if it is true, it will print output A. It will print the value of A. Suppose if A value is not greater than B, it goes towards false direction and prints the value of B. A will not be printed. So whether it is true or false, later on it will come back to stop on. Similarly, finding sum and average of numbers. So for this, before I ask a number, for example, if I say 5, so you have to calculate sum of all numbers from 1 to 5, because I said number as 5. 1 to 5, all numbers sum should be calculated. Then later on, average should be count also, it should be calculated, because it is required for calculating average. So before they start asking the value, first sum and count variables are initialized. Sum and count variable are initialized to 0. Then they ask for input number. In number is what? Up to what range you want to calculate the sum. And okay, no, it's not that one. It is a different one. See, this program is about, they will go on asking the numbers. User has to input different numbers in every rotation, and those numbers have to be added. And at last, it should keep track of how many numbers are entered. And at last, when they don't want to feed some more numbers, they want to stop at some stage, it should come out and then it should calculate average and print sum and average. First, they are asking for a number using input box. That number feeded by you will be added to the sum and result will be assigned back to the sum. And count will be incremented by 1, indicating that you have entered one number. Then it will ask you more numbers. Do you want to continue entering one more number? If you say yes, it will go back to the section for asking one more number, right? When you say that I don't want to enter the number, one more number, I don't want to continue entering the number, then you have to say no, it will come out. Then average will be calculated where sum divided by count. Total sum of all those numbers you entered by you divided by how many numbers you have entered. And at last, using input output box, the sum and average is being printed and stop. And then write a flowchart to find the sum of digits in a given number. That means what? Digits in a given number means if the given number is 123, your program should calculate 1 plus 2 plus 3. So when you want to calculate this 1 plus 2 plus 3, that is sum of individual digits present in a number. Like for example, if I am entering 546, your program should calculate 5 plus 4 plus 6 or 6 plus 4 plus 5. Anyway, right? For that, you need to know the manual procedure in the mathematics, what is available to calculate the sum of individual digits. That I'll show you here. If the given number is n, 123, how to first what? You have to extract the digits out of the whole number. How to do that? What I do is, say I'm writing reminder equal to the given number 123 modulus 10. Modulus means, you remember, it gives you the remainder of the division. Right, 10 12s are 120, 123 minus 12, 123 minus 120 is 3. The 3 is the remainder. That 3 will be in the remainder, and what I do, I'll add it to sum. Now it is, sum was 0, 0 plus 3 is 3 now. That means what? When I did modulus of 10, I got last digit as a remainder. One digit I extracted now. Next, I should go for extracting the second digit. How it should be? When I do modulus 10, always it will give you the last digit. As the number was 123, so I got 3. But next time I want 2 as a reminder. So what I do, I'll reduce that 123 by one digit by writing 123 divided by 10. 123 divided by 10 means 12.3. So in the programming, we are going to take some numbers as integers. Integer means a number without decimal part. So 0.3 will be removed from this. The left out value is 12. Now I repeat the above process, this one, for the value 12. Earlier it was of 123, no? Now it is 12. 12 modulus 10 means the last digit is 2 as a reminder. Earlier sum was how much? 3. Now present reminder is 2. Here the reminder was 3. Here the remainder is 2. That 2 got added to the previous sum. 12 divided by 10 means what? It is 1.2. As we are taking integer number, no decimal, so 0.2 will be removed. 1 is left out. Only one digit is there now. And now what I do? And now I'll do this process for digit 1. When there is a single digit, modulus 10, the same digit will be returned as a reminder. That will be added to the previous two reminders. And 1 divided by 10 means it is 0.1. 0.1 will be discarded, only 0 will be left out. That says that in n, all digits are extracted. In 123, you see 3, 2, 1 got extracted. There are no more digits in this. Stop the process. And the output is what? Sum. What is the final sum? 3 plus 2 plus 1 is 6. This manual procedure you should know. Then only you can write algorithm. then only you can draw algorithm or flow chart. Then based on that only you can write the program. Without this, if you go for directly drawing this flow chart, if you try to study, then you will feel what this modulus, why they added it, why they have done division, this all difficulties will create. That is why go in this way. So start, you need one number, sum we need to have initially 0. Is n not equal to 0? Because the process has to be continued until n becomes 0. That's why check is n not equal to 0. If it is true, right, then n modulus 10 remainder should be extracted and it should be saved into the REM. That REM remainder will be added to the sum, the final sum assigned to this sum, divided by 10 for what? Deducting the given number by one digit. When n becomes 0, so it will come out from the program, it goes to the print sum. But until n is not 0, this process, you see the arrow, the direction, it is like loop, repetition. It will be happening how I did here 3 times. In the same way, the same process was repeated 3 times. The same way here also it is done. Then stop. Then flowchart to check whether the number is prime or not. Once again, to check whether prime or not, you must know the manual procedure. First, you need to say start, input n, limit equal to square root of n. First, they are calculating the square root of n. Right. Then they are taking something called as a for, which is for repetition. Right. For I equal to 2 to limit from the value 2 to the value what we have received in limit. That is nothing but square root of n. If n modulus I is equal to 0, what is prime number? A number which is divisible by itself and not by itself and 1 and not divisible by any other number is a prime. So from 2 up to the limit they are doing. In this range, if n got divided by any of the number, then it is not a prime. If it didn't get divisible by any other number, it's a prime. Okay. Then coming to the pseudocode. Let's start with testing and debugging part. Testing means running the program, executing all its instructions or functions, and checking the logic by entering the sample data to check the output. See, testing is one of the very important steps in problem solving. See, once, say, a software engineer or the team develops the program and give it to the testing team, what testing team will do? So they'll execute the program, right? And they have to check whether the expected output will come or not, and any errors are there or what, by giving sample data. Based on the various sample data given to the program, if it is working perfectly, then the program is like successful, right? Until and unless this team clears that this program is tested okay, so we can't move it to the further section. And debug in the sense what? It is the process of finding and correcting the program code mistakes that are called errors. See, during the testing, if they come to know that this is not working for this set of data, this is not giving proper result for this type of data, or while executing the program only some parts are not working properly, it is getting hanged, it is getting stuck in between. Then finding and correcting those errors, right? Finding and correcting errors in the program code is called as what? Debugging. There are 3 types of errors: syntax error, runtime error, logic error, right? Logic errors are also called as what? Bugs. So here, field testing. So here in this case, types of errors, about types of errors we are going to study here in the role of compiler. So now field testing is realized by users that operate the software with the purpose of locating the problems. See, field testing in the sense what? They are going to see, sometimes you might have seen that when the software is completely released to the public for usage in the internet, you will be seeing that some beta versions will be releasing. In those beta versions, what happens is it's a field testing. When they release such kind of software, the people will start using it, experts will start using it, and they'll, while doing working with that software, whatever the errors they get, they will update it to the company so that the company will rectify those and give the final product. That is field testing, right? So in order to achieve the required output, the program that is written in coding phase must be tested, compiled, and then executed. So what is the role of a compiler? What is, see, first of all, compiler means what? It is a translator for high level language, which translates source code of high level language to machine level language, machine language. So the first task of the compiler is to analyze the program for correctness and detect errors if there are any, right? Once if there are no errors, suppose if there are any error, stop the program, give the message to the user that in this part, this kind of error is there. By seeing that, the program will make the necessary corrections. Once all the corrections are done, then it will make the translation, right? So here, during the compilation, certain errors are detected by the compiler and then indicated. These errors constitute the grammatical errors in the programming language, and these are called as what? Syntax errors. So syntax errors in the sense what? These are the errors occur when grammatical rules of the programming language is violated. Assume that you have written a sentence in the English. As per in the English, in that sentence, we have to use was, but you have used is. The English teacher, when they are checking, they'll round up that word and say that as per the English rule, here was should come, but here written is, right? So that is what syntax is. Similarly, in the programming language, when you are writing the program, if you are making any mistakes, right? Mistakes while writing the statements of the programming language, if you are violating any rules of the programming language, then it is going to be considered as syntax error, right? So we have, see, one program is there, int xy, which is written in C++, int x comma y, and here type 2 integer value, cin is there and cout is there, return 0. In this problem, here after x comma y, semicolon is missing. That is one error. Second error is what? At the end of the scene, instead of giving semicolon, they have given colon. That is another syntax error. And at last, return 0. There also you see that they have not given semicolon at all. Semicolon is required. In such case, when we give this program to the compiler, it will list out all these problems, right? And then it will inform the user to rectify. Once when it is rectified, when it is recompiled, if everything is correct, then the program compilation will be completed, then the program will be executed, right? So during the, see, once after all these syntactical errors gets cleared, your program will get executed. Your program will be sent to the CPU for execution. It will execute, but at the time of executing, some more errors may occur. Such errors we call it as runtime errors. Runtime errors which are not syntax errors. Kindly note, which are not syntax errors. So runtime error in the sense, assume that you are writing a division of two number program, but while inputting the values for two in numerator and denominator, by mistake or intentionally, you gave the denominator as 0. As per the mathematics, a number cannot be divided by 0. The result is going to be infinite. So in such case, what happens is a number cannot be divided by 0. Division by 0 error will be displayed. Division by 0 error will be displayed. These errors are corrected by modifying and recompiling the source program and then execute the object program again. Runtime errors are frequently known as bugs. Runtime errors are frequently known as bugs. So this word, bugs, it's a quite common word or frequently used word in the software development field, right? So these are what? Bugs. And now we have semantic errors. The semantic in the sense what? Consider an expression here y equal to a plus b, indicating that the values of a plus b have to be added and result has to be assigned back to the variable y. If written as a plus b equal to y, though values of a and b are added, it cannot be assigned to the variable y because that single equal to sign what they have used as per the programming language, the right side value will come to the left side variable name. As right side we have a single value, that is okay, but right left side we have a plus b, which is there must be a single variable name which is not there. That is why it is called as what? Semantic error. And debugging in the sense what? It is the process of identifying and correcting or removing the bugs, errors is called as what? Debugging. Sometimes program may have errors known as logical errors. See, programs may also have a third type of error called logical error. Logical error means what? Here, the expected output is not coming, right? The compiler will not say anything about your program that, see, your program is wrong. There are no runtime error, there are no semantic errors, syntactical errors, right? Program is running fine. I'm feeding the input, but the expected result is not coming. In such case, what? Such kind of errors are called as what? Logical errors, which will not be notified by compiler to the programmer. By seeing the output, when you come to know that expected output is not coming, then you must come to know that it's a logical error and you have to check the program logic, what you have adopted. Because of that only, because of the wrong logic adopted in your program, the final result is not coming properly. So you have to check the logic and you have to make the necessary changes in the logic and you have to rerun the program to get the correct output. That is what? Logical error, right? So documentation, and one more thing, testing a program for correctness is an essential step in obtaining the successful computer solution for a given problem, right? So it's very important section, testing. Testing of a program is a process of executing the program with set of sample data and check the output for correctness for various. See, have you seen? If you want, I'll show you one video. Wait. Here, I'll go to YouTube. And here in the YouTube, I'll try to check bike testing in factories. So if you are seeing these kind of videos, Panda bike testing is there here, right? So this first one is best, I think. So here, see there, the vehicle is standing there only. So it will be checked in all the variety of things. Speed checking, see everything, right? So there you see in the monitor, it is showing you all the results. It's like inspection. See, there is a sample road, there is a hump, everything will be there. There will be a rough road, right? In all those conditions, how this will react. Sometimes even temperature checking also, right? So every stages will be checked. After that, what happens is bike will be released for the market, because a bike manufactured in the USA may not fit for our Indian roads. But nowadays, no problem. Our Indian roads are very good than other countries, right? But still, right? See, all types of checking will be. Even in field also they'll go. So like this, without testing the product, they can't release for the market. In the same way, in the software also that section will be there. But there, how different roads they'll use for testing, no, like that here, by giving different variety of data, they will check. One example, I'll give you a program to write a program to read the percentage of a student and check whether it is pass or not. So your program will ask the percentage, you enter 40, your program says pass. Then you enter 20, second time, your program says fail. Fine. But the testing team, you know what they do? Enter the percentage. They write 150. Your program is saying pass. So your program is failed in the testing. Because the maximum percentage is what? It is 100. Second round, they enter negative value. Your program says that failed. Here, 0 to 100 is the valid percentage. Next time when you run it, what is your percentage? My percentage is 95. I'll write it in spelling. Right? Your program got stuck. That means this is your program's failure. These all kinds of sample data, by giving it to it, they'll check in all the ways whether it's working properly or not. And coming to the next section, documentation and maintenance. The documentation in the sense what? Once after developing, right, a proper documentation has to be provided to the user, right? So it's a reference material which explains the use and maintenance of the program. Once again, I'll come to the bike or a mobile or a car, you buy anything, there will be a user manual. In the same way, that user manual, here we call it as a documentation material, which will help the user to understand the procedure of how to use the software or a program, and how to do the maintenance of the program or application for which it has been written. So it could be in the form of a separate printed document or as a help file in the program itself, right? Earlier we used to have a like offline help file in every software, but nowadays what, because of help takes little more memory, majority of the software companies, they are making the help documentation material as a online material, right? So there are two types of documentation: internal documentation and external documentation. Internal documentation is also known as a technical documentation. It is meant for the programmer who update the program code at a later stage. It is not for the person who is using your program. It is not for end user. Right, it is for the internal documentation. It is only for the, assume that this software was written by 3 programmers A, B, C. They developed it, so that software got sold in the market. Thousands of users started using that product. After few years, these people, A, B, C, left the job in the company. So to their position, PQR, 3 new employees came. That moment, they got a situation of improving that software or a program. Then how they should come to know that, what all the things, what idea was there in this program at the time of development, which was developed by those previous employees. Now those three previous employees will not come to the company and will guide these new employees. They have left the company. Then who will help? This internal documentation, which will be written in detail, which will be helpful for these employees to do the modifications, right? Additions, improvements. They can do it by using this internal documentation. It is only for the programmers, not for the end users, right? So that is what all the things, what it is done by what? Defining meaningful variable names, including remarks and comments for each and every codes written in that sections. For what purpose this particular type of section is written, that is all indicated, and adding remark on every module indicating its purpose. Adding remarks on every module indicating its purpose. Presenting the program code clearly by inserting spaces, blank lines, and using indentation. Right. So now it is external documentation is for the user who uses your software. It will be provided separately as a supported document, and it will be in the textual format about the application, how to use. It is for the user, administrator, even for the developer, right? There are three types of documents: user's manual, administrator's manual, developer's manual. User's manual contains operating instructions of that software, each and every section, how to use. Procedure, how to do different operations in that detailed procedure will be. For administrator's manual, it contains instructions for the user who is going to manage that application for them, what kind of admin operations will be there, no? How he has to handle different admin operations in the future. Developer's manual contains low-level flowcharts, data dictionaries, decision tables, files, and the complete system chart, so that application can be easily updated. It's like internal documentation, like, right? And the maintenance. Once the software is sold to the customer, now maintenance has to be done. See, for example, once when you company sells the motorbike to you, they have to have one service section in every showroom. They have to give the service, right? So I am buying a Honda bike, and for service I can't go for Hero company. I have to go for Honda company only. So those people have to give all the original spares, proper servicing, everything they have to give. That is maintenance. So programs that are developed become outdated with time. Sometimes errors may creep in. Depending on the changing rules and the user's requirements, program need to be modified at time to time. Right. So program maintenance means periodic review of the program, additions, modifications, deletions, as per the requirement of the user. That process will be it will be continuing. So to improve the clarity, fresh documentation every time it will be prepared. Maintenance is what? It's a continuous task. It is never stopping task. Documentation plays an important role in the program maintenance. Right. Next is program constructs. What are the different types of program constructs will be there about that? Every language has its own syntax. Syntax means what? Method of writing command. Every language will be having its own syntax for each and every command. What you are going to write it, that program, using that programming language. So those syntax will tell the programmer how exactly that statement should be written. Right. In English, language words, sentences, paragraphs are constructed using character set and punctuation marks. A computer language will also having its own character set, or which are the basic building blocks of the program. Right. So that character set is required. So pseudocode is another notation for expressing an algorithm. It is a mixture of English and computer instructions. Right. See, in the algorithm, you had seen that they wrote input A, comma B, comma C. Right? They wrote print. They wrote if. So, by using English words and by using some words like programming constructs, but actually they are not programming constructs. Computer instructions like. By mixturing these two, they are going to write it like algorithm. That is what pseudocode, where different programming computer words will be there. So there are three basic programming constructs: sequential, selection, iteration. Sequential, selection, iteration. Three sections will be. Sequential means what? Set of statements working systematically. Means sequentially, one after another, like how it is shown in the diagram. Only one entry point, only one exit. There are no other ways to go out of the program in between. After S1, it should come to S2 only, then S3 only, then S4 only. Then after that, immediately go out. There are no alternate ways. Right. In that, it can be like a input statement, assignment statement, output statement. They can be considered as a sequential construct. Where in this input statement, these are used for inputting the values to the programming variable. Right. When they write input A, comma B, comma C, it says that input the values for A, B, C, whatever you type, that value will be sent to this variable. And those values will be in the memory for until the further process is completed. Assignment statement means what? See, there they have written A equal to B, single equal to sign is the assignment statement. A equal to B means the value present in the right side variable B will be copied into the left side variable name A. Right. So similarly, C equal to 10, we should not say. We have to say 10 is assigned to the variable A. Right. So now, output statement is for printing the message on the screen, on the standard output device. The word like output, display, print, these three words we will be using in the pseudocode. Pseudocode, right? Selection statements in the sense what? It will help the programmer to take appropriate action, decision based on the input values provided. Right. So there are 5 kinds of selection constructs. They are simple if else, if and multiple selection. And statement 1 can be simple or complicated. If there are more than one statement comes, then you can enclose them into a flower bracket. There are no like issues in that. See here, the if condition graph. Sorry, it's a flow chart. Is a test condition false and true. False means it will come out directly to the end of the program, end of the statement. Whereas if it is true, statement 1, which is statement 1 will be executed, then it will go to the output. Right. If amount is greater than or equal to 5,000, discount equal to amount into this. Right. Next is if statement. If statement is also called as a decision-making statement. Decision-making statement. Right. Where set of statements should be executed, single or set of statements will be. What happens when the condition, whatever they have provided based on the result of the condition, the respective true condition or false condition will be executed. Right. See now the general form of if else. if test condition statement 1, statement 2. That means if this condition gets true, then statement 1 and statement 2 will be statement 1 will be executed and statement 2 will be skipped. Whereas if the condition is false given by you, so second else section, whatever you have written, it will be cancelled. Right. Suppose if the condition is false, test else statement 2 will work, but statement 1 will be skipped. Right. If condition is true, then execute statement 1 and come out from the program. That means what? Statement 2 will not. If it is false, then only statement 1 will work. Right. And these things, like this, it flows continuously with the remaining steps. So the test condition is tested. So here, there are some examples. If amount is greater than or equal to 5,000, discount equal to discount into 10 divided by 1,000. So now you see, if amount is more than 5,000, this formula will work, and the part which is present in the else will be cancelled. Whereas one more thing, see, if n modulus 2 is equal to 0, they have written one print and then else, after that one more print is there. Now in this case, what happens, if this condition is true, this message will be printed, otherwise this message will be printed. So now here, based on this, first if else if statement. So now you can see that if else if statement, in the sense it's a chain or multiple conditions. When you want to handle, you can go with multiple way branch or if else if statement. This is very important. All right. So the general form is, if test condition 1, if it is true, statement 1 will work and all the if else if everything will go. If it is not equal to 1, then it will continue. Right. So for that, see, if condition 1 is true, statement 1 will work and will come out from the program. If it is else, then next check the second condition and statement 2 only it will be executed if the condition is true. Otherwise, else, it will execute the statement present over here. Right. And in the else, what they have done, one more test condition they have. If that is true, then final output will be true. Right. And there is a flowchart, the representation of that previous program. If the condition 1 is correct, statement 1 and go to the end of the program. If it is true, go to statement 2 and work with the remaining programs. Right, like this, it will work. And all files line, you see, it is at stop only at the end. So that explanation they have given. If marks is greater than or equal to 45, 85, it is distinction. If marks greater than or equal to 60, it is first class. And when it is not 60, then check. It will be second class. Otherwise, the else for this one, this step, marks greater than or equal to 35, then print a proper message.